Good day, my lovely viewers. Welcome to this YouTube channel. I wish you a happy Merry Christmas in arrears and compliment of the season. Today we shall be looking at circle theorems. This is one of the major problems in mathematics that students do find difficult in exams. But today I'm going to be giving out the basic introduction to circle theorems by stating the theorems one after the other. Okay, let's get started with that. Now the first theorem simply states that the angle which an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of the word circumference. I take that again. The theorem simply states that the angle which an arc of a circle subtends at the center is twice that which subtends at any point on the remaining part of the word circumference. Let us consider a diagram here. Let's consider a diagram here. Okay, now we have a circle. This is a circle. Then we have an arc. This is point O. That point O simply signifies the center of that circle. So let me call this point A, this point B, and this point C. So this theorem simply states that the angle at the center here is always twice the angle at any point on the remaining part of the circumference. So let's assume this point is point X, point A, but it's having an angle X. So that means the angle I'm to have here is going to be what? 2x. So that means angle at center. For us to have this angle at center, it must be twice of any angle you have at this what? At this point. Okay? So that means I can simply say that angle BOC, which is BOC, is equals to twice angle BAC. So let me put that in words. Simply states that the angle which an arc of a circle subtends, sorry, my black marker is not that effective, subtends at the center is twice that which it subtends at any point on the remaining part of a circumference. Now this is the first theorem. Now let's go with the second theorem. The second theorem is very simple and short. That simply states that the angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. That is, we are considering another circle here. This is a circle. Okay? A semicircle simply means half of a what? Half of a circle. So that means I have this point as my point O as well. So whatever angle I have subtended at any point here is equals to 90 degrees. So if I call this point A, point B, and point C, so that means angle in a semicircle at this point is 90 degrees. That means angle B is equals to 90 degrees. So let me put that in words as well. The angle in a semicircle is 90 degrees. Okay? So this is first and second theorem. So let's go with the third theorem. Sorry? Okay? You can feel free to pause the video and write the theorems one after the other. So let's go with the third theorem. Now the third theorem has to do with a quadrilateral. The angle, the opposite angle of a cyclic quadrilateral are supplementary. That simply means that supplementary simply means they add up to what? 180 degrees. So now let's do that here. If we consider a circle again. Now a quadrilateral has four-sided shape, which is in the circle. Why we call it cyclic is because it's embedded in the circle. Okay? Now this is a quadrilateral with four sides. Are we together? So whatever, let me call this point A, point B, point C, and point D. So let's say this angle here is angle X, and the angle here is angle Y, and the angle here is alpha, and the angle here is what? Beta. So the theorem simply states that the opposite angle of a cyclic quadrilateral are supplementary. That means they are add up to what? 180 degrees. That is, X plus Y opposite to each other is equals to 180 degrees. Alpha plus beta equals to 180 degrees. So if you match these two particular values together, you have sum them together, you have x plus y plus alpha plus beta equals to what? 360 degrees. So this also verifies a lot of what polygon that states that in a polygon, total sum of the angle there is equals to what? 360 for a quadrilateral, which is quadrilateral with four-sided shape. Are we together? So that means when you put that 4 into that formula for polygon, you still have the same 360 degrees. So the total sum of this angle is 360 degrees, but the opposite angle in a cyclic quadrilateral add up to what? 180 degrees. Okay, let me put that in words as well. Opposite angle of a cyclic quadrilateral are supplementary. That is the third theorem. Now let's go to the fourth theorem. Now, the fourth theorem is more or less like the first theorem I state. Now, this theorem simply states that the angle in the same segment are equal. The angle in the same segment are equal. Now, let's do that diagrammatically as well. If you consider a circle here, are we together? Of course, like just like the first diagram I drew, she's something like this. Okay, so these are segments. These two particular lines here, these two particular chords here, they are coming from a particular segment. So that means whatever angle, whatever lines again coming from that same segment, like this, they are said to be equal. That means if this is x, this is x, this is also what? X. That is angle in the same segment. They are coming from the same source. They will be what? Equal. And of course, if the center O, this angle will be equal to what? 2x, just like the first theorem. Are we together? So I can call this point A, point B, point C, point D, and point E. So therefore, angle A is equals to angle B is equals to angle C. Are we together? So the theorem here, let me state that. The theorem here simply states that the angle in the same segments are equal. Okay? Now let me take the fifth theorem. Now, the fifth theorem do with a quadrilateral again. This theorem simply states that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Let me take that again. The exterior angle of a cyclic quadrilateral is equal to opposite interior angle. That is, of course, this is a quadrilateral. So if there is an extension, let me call this point A, point B, point C, and point D. So whatever angle I have here, let's say this angle is X. The angle is also what? X. That means exterior angle of a cyclic the quadrilateral is equal to opposite interior what? Angle. So if this is point X, this is also point X. And if there is another extension here as well, if this is point Y, this is also going to be what? Point Y. Okay, so that means we have angle D equals to angle A, and also angle B equals to what? Angle Y. So let me put that again. The exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Okay, these are the 5 theorems, but we still have more to come. But I'm going to stop here for today. Feel free to ask your question and drop your question in the comment section. And don't forget to please like this video, subscribe, and share this video to enable you get more info about my coming videos. I'll see you guys in my next video. Stay tuned. Bye for now.